Welcome to a basic review of the concept of a function. We're going to quickly look at what a function is, how we use them, and some common mistakes you should try to avoid. At its core, a function is nothing more than a rule for taking an input and giving an output. The inputs and outputs don't have to be numbers, but in order for the rule to be called a function, it needs to be well defined. In other words, if you're the function and you're given an input, you need to know exactly what to do to give back one output. We can define functions in a lot of different ways: words, formulas, lists of inputs and outputs, and graphs and pictures. A few examples. If you take a number, double the number, add 5, and then return the result, you get a function. A more abstract way of describing the same function is if you're given an arbitrary number x that's unknown, you can return 2x plus 5, or twice the number, and then add 5. The notation we use involves giving the function a name and then indicating the input inside parentheses. Tradition has us use f and g as the names of the functions most of the time, unless the function has another natural name. We read the parentheses like this as f of x. So if the function f doubles the input and then adds 5, we would read this as f of 12 is 29. Or doubling 12 gives us 24, adding 5 makes it 29. F of negative 3 is negative 1, and more abstractly, f of x is 2x plus 5. We can also identify the input and the output from an equation. If we know that g of 3 is equal to 7, then g is the name of the function, 3 is my input, and 7 is the output that g gives for an input of 3. Most of you will be fairly comfortable with this notation, but it's more difficult to read once we start putting two functions together into a composite function. At its core, the composition of two functions is just taking one function first and applying the second function to the output of the first. Symbolically, we read the composition from the inside out. If x is the input to g, then we get an output called g of x, which we'll use as an input of f, giving the output finally f of g of x. This is the single number given from an input of x going through g. So as an example, if f of x is the function 2x plus 5, and g of x is the function x squared, then the composition f of g of 3 can be read from the inside out. We take 3, apply g to it, giving 3 squared, or 9. That becomes the input to my outside function f. So f of 9 is 23. That is f of g of 3. More abstractly, if we have an arbitrary number x, we would apply g to it first. G of x is x squared, so that becomes the input to f. And then we apply f to x squared as my input. X squared as the input takes the place of the input here. The input here is x, so we end up with 2 times my input plus 5, or 2 times x squared plus 5. Note that g of f of x is something completely different. The order of operations is extremely important. With g of f of x being 2x plus 5 is my input to g, so I end up with 2x plus 5 all squared, and that's a different function than 2x squared plus 5. In particular, g of f of 3 is 121, which is not the same as 23 here. Some of the common mistakes that I would like you to try to avoid involve both semantics, how we refer to our functions, and what you can do to the input. So, first things first, f is the function, f of x is a number. Typically in this class, you're going to refer to the output of the function. You're going to be referring to f of x. There's very few instances where you want to talk about f by itself. So make sure that you indicate the input when you're talking about your function. Also, when you do something to the input, when you're looking at a composition of functions like this, then that input is plugged into the entire function f. F applies to this entire input. So you normally can't do what I have listed here. F of x plus 5 is not the same thing as f of x plus 5. You can't apply f just to the x part. The reason this is important is that these composite functions come up a lot in calculus. When we're talking about how to define different parts of calculus, we're going to use these compositions. And we can't do something that's not going to give us a valid output. So things that we see very commonly are inside radicals, inside trig functions, inside squares. A lot of people want to use the addition as something outside of the function, and it just cannot be done. The thing inside the function has to stay inside the function until things get simplified. So With trigonometric functions, with radicals, and with squares, be especially careful that you don't change the input. In the second video, we're going to use a graphing program to look briefly at some of the most common functions we'll see in the class, including the trig functions, and we'll look at some of the graphical properties.